Okay, in this video we're going to be using long division to divide p of x by d of x. P of x is x to the third plus 5x squared plus 6x plus 9, and d of x is x plus 3. The first thing we need to do is set it up for a long division problem. So we're going to have p of x, since that's what is being divided, going underneath. So we'll have x cubed plus 5x squared plus 6x plus 9. And then the divisor is the x plus 3, which will go out in front. Now that it's set up, it's very similar to long division with regular numbers. We need to figure out how many times our expression, our expression, x plus 3 goes into the polynomial. And the way it works with polynomial long division is you're going to focus on the first term of the divisor and the first term of the dividend. We need to know how many times x goes into x to the third. In other words, we're just going to take x to the third and divide it by our divisor's first term, x, which gives us x squared. So we know x goes in x squared times. And we're going to place this, I like to place it so that everything is lining up with terms of the exponents. So I'm going to place the x squared over the x squared. Doesn't really matter much in the long run. But now on my next line, just like with regular long division, we're going to have to multiply what we just found times our divisor so that we can subtract and continue the process. So we're going to do x squared times x plus 3, and we'll write it down right there. If we distribute, it will give us x to the third plus 3x squared. The next step we would do, just like in regular long division, is to subtract, which can get a little bit weird because of the two terms. But we have x squared minus x squared, x cubed minus x cubed, which cancels out. And then we have 5x squared minus 3x squared, which is just 2x squared. And then just like in regular long division, we'll bring the next term down. Now we just repeat those couple of steps over and over and over again. So we'll focus on the first terms, and we'll take 2x squared. We'll divide it by our leading coefficient of x for our divisor, giving us just 2x. So plus 2x will go on the top. And then we'll repeat the process. We'll multiply that 2x by our divisor of x plus 3 to get what we need to subtract. Distributing it through, I get 2x squared plus 6x. And now we'll subtract. 2x squared minus 2x squared cancels out. And 6x minus 6x cancels out and gives me 0. We'll bring down our next term of plus 9. And now, normally we'd have to continue this process. It may even help to have it as 0x. However, there are no longer any x's. So this 9 is going to be our remainder. Once there are no x's, you won't be able to continue the long division. So whatever is left is the remainder. If your divisor is a linear expression, like it is here, no exponent, then your remainder should just be a number if you have one at all. If it's a quadratic, it could be a linear expression. The remainder could be 1 degree less than what you're starting with. But with that, we have a remainder of 9, and there is one other way to write out the answer besides what you see up top here. More commonly in Algebra 2, you would see the answer written as x squared plus 2x plus 9 over the divisor of x plus 3, because 9 is the remainder of what we couldn't divide by x plus 3. And that's usually how you will see it expressed in Algebra 2 and other math courses, instead of writing the R9 like you did with long division in elementary school. Though, long division in elementary school, this is actually what the remainder stands for. Just as a side note here, if you're dividing 7 by 4, you would end up with 1 and a remainder of 3, which correlates to 1 plus 3 over 4, which, if you didn't know, as a decimal is 1.75. So just a fun relation with how this is set up compared to what you may have done in elementary school with regular numbers. Okay, here we have a second example of using long division to divide our polynomial p of x by d of x. So if I set it up this time, we're going to run into an issue. I'm going to switch back to the last example I did. If you look at how this example is set up, you might notice that all the x cubes lined up with all the x cubes, all the x squareds line up with all the x squareds, all the x's line up, and so on. It's very important when you're doing the long division that you have everything lined up so that all the powers are in the correct spots, so you can easily do the subtraction. However, if you look at what we're dividing this time, our current dividend, you'll notice that it goes x to the third, and then it doesn't have any other x's. That creates an issue with getting things to line up like they do in the previous example, making it easier to do the actual division process. So in order to get things to line up, to get our terms to line up, what we end up needing to do with this is we need to put placeholders for any missing exponents lower than the highest powered term. So we need to put 8x to the third, but because we're missing an x squared term, we're going to put plus 0x squared as a placeholder. Then we're going to put plus 0x as another placeholder, and then plus 27. Any missing exponents you need placeholders for. Otherwise, things are not going to line up, and you won't be able to do the subtraction throughout the process. On the outside, our divisor is 2x plus 3. And from here, it's basically the same as what we just did. We have to divide or figure out what to multiply by. So we're going to take our first terms, the 8x to the third, and divide it by 2x, which is going to give me 4x squared. So I'll place that on top. Then we'll multiply 4x squared times our divisor of 2x plus 3. Distributing it will give us 8x to the third plus 12x squared. We'll subtract, just like in long division. So we have 8x to the third minus 8x to the third, which once again cancels out. If that first term doesn't cancel out, something is wrong. 0x squared minus 12x squared. Well, 0 minus 12 is negative 12. So negative 12x squared. Drop the next term down, so plus 0x comes down. And repeat the process. So we need to find what we need to multiply by. So we're going to take our first term, which is the negative 12x squared now. And we'll divide it by our leading coefficient for our divisor, 2x, giving us negative 6x. Now just repeating the same process, we'll take the negative 6x and multiply it by our divisor, 2x plus 3, to figure out what we need to subtract. Negative 6x times 2x is negative 12x squared. And then negative 6x times 3 is negative 18x. Just like in regular long division, we subtract. Sometimes with the double negatives and stuff, it can get a little confusing. So right now, we are going to be doing negative 12 minus negative 12. Just writing it up in the top corner. And that's what's going on there. That double negative there makes a positive. So negative 12 plus 12 does cancel out. Same thing with the other terms. We have 0 minus negative 18. So writing it out again just to emphasize. That double negative, the minus negative 18, makes a positive. So it's really 0 plus 18, which is 18. So we have 18x there. And I forgot to write something on top. I forgot to write my negative 6x on top. Got too carried away with things. To finish it off, we have one more iteration of the cycle to go through. So I'll bring down my 27 and do the same process again. We're going to take my 18x and we'll divide it by our leading coefficient, or our divisor, which will give us 9. X's will cancel out this time. So we'll put plus 9 on top. And then we'll multiply our divisor by our 9. So 2x plus 3. So distributing it through, we get 18x plus 27. Then, of course, just like regular long division, we subtract. So 18 minus 18 cancels out. And 27 minus 27 cancels out again. So we're left with 0. So this time we don't have any remainder, and our answer is just the 4x squared minus 6x plus 9.